Last lesson, we looked at scaling or dilating our graphs and reflecting our parabolas. Today, we're looking at translations. So if you remember back with your geometry transformations, we talk about translating, rotating, and reflecting. A translation means that we're just shifting the graph or sliding it left, right, and up and down, or maybe a combination of the two. So a translation is a shift of all the points either horizontally or vertically. Unlike a dilation, it doesn't change the shape of the graph. Okay, so it's going to be exactly the same shape, but just moved in one of those directions. What we're going to start with is the vertical translation. If we're moving a graph vertically, the graph will have an equation of y equals to x squared plus k, where k is some sort of number. So if k is positive, it means that the graph is going to shift up by by k number of units. If k is negative, it's going to be shifting down. So if we have plus 1, what that means is, so if I have y equals x squared plus 1, what that means is when we're starting with x squared, all the y values are going to be 1 unit above the original. Whereas if it's a negative, so if I have y equals x squared minus 2, if I were to draw out a table of values, then all the values will be 2 steps below. So you can see that the k value will tell you exactly how much you're going up or down. So here's our first example. Sketch the graphs of y equals x squared, which I've already done for you. We're going to sketch x squared plus 4 and x squared minus 1, showing any key points. Okay, so key points are going to be important things that tell the difference between each of those three graphs. So we've got x squared already. If I need to draw x squared plus 4, the plus 4 tells me all the points are going 4 units upwards. So what I'm going to do is I'm going to copy my graph. Oh, I've only got half of it. I'll draw the other half in a moment. So there's half of my graph. I'm going to move that 1, 2, 3, 4 units upwards, and that's going to be where my new position is. So what I can do is I can take the other side and do the same. So 1, 2, 3, 4, it's going to pass through here. So let me just change the colors. That's going to be the graph of y equals x squared plus 4. So again, we don't need to plot points or anything. We're not measuring anything because it is a sketch. But what we can do is we know that this value is now moved up to 4. So what we can do is we can label that y-intercept with 4, and that would be the key point that we want to show. For our next graph, we're looking at y equals x squared minus 1. So what's going to happen is we're going to take the graph and we're going to move it one step downwards. So I'm going to take this side again. So we're starting here, we're going to go one step downwards. And I'm going to take the other side, copy, and I can also move this bit one step downwards. And so that's where it's going to end up. So this new graph is going to be y equals to x squared minus 1. So you can see they're never going to touch each other because it's just the same thing going up and down. So think about when you've got a shape, if you move it up and down, they're never going to intersect each other. But they're all going to be sort of like close to each other. We can label the y-intercept, that's going to be -1. And later on, we're actually also going to work out what these x-intercepts are. For the time being, we're not going to worry too much about those, but how we would find those is by solving a quadratic equation. So that's going to be much more important later on. At the moment, we're just looking at shifting it up and down and just sketching where this graph lies. The most important points will be your y-intercepts here. All right, so that's our vertical translation. So y equals x squared plus k. So the plus k tells you how much you're going and which direction you're going. We're going to also look at horizontal translations. So horizontal shifts means that we're going left and right. So if I start with parabola here, then what I want to do, copy, is I want to take this parabola I want to move it this way or that way. Okay, so that's the directions that we're going for this section. To move this, this part of the equation is y equals to x minus h squared. It's really important that it is a minus in the middle. You will see y in a little bit. So if h is positive, then the graph is moving towards the right. If h is negative, then the graph is going to be moving towards the left. So just a really quick example here. So let's say if we were looking at x squared and then x minus 1 squared. Okay, if we were to look at a table of values, so let's go minus 2, minus 1, 0, 1, 2. Just a couple of really quick numbers. If we're looking at x squared, then we've got 4, 1, 0, 1, 4. If we're looking at x minus 1 squared, then the minus 1, we've got negative 2 minus 1, that's going to be 9, 4, 1, 0, 1. So what you can see is that these values have all been shifted across towards the right. Okay, so now rather than the 0, the y-intercept being at 0, it's now where x is equal to 1. So if you were to draw that, it would be like this top diagram here, where this value here is 1. So you can see it's sort of, if it's a minus 1, it's a movement towards the right. So that's something really important to remember. So let's have a look at this really quick example. We want to draw y equals x squared, y equals x minus 2 all squared, and x plus 3 all squared. So y equals x squared, that's just going to be our normal sketch of our parabola. Hopefully you're getting a bit used to drawing these U shapes. The next one is y equals x minus 2 squared. So remember, we said minus 2 means that we're moving 2 units to the right. So that means our new 0 is going to be at the value of 2. So in other words, you're sort of like looking at this. What value is going to give us 0 here? So if x minus 2 is 0, then x must equal to 2. So that's why that's going to be where the vertex is. So what that means is we're going to take this graph, copy it, paste. We're starting here, and it's going to move 2 units to this position right here. So this is going to be the graph of y equals to x minus 2 squared. Now, it is usually important to find the y-intercept as well. To find the y-intercept, you're going to make x equal to 0. So then you can see the y value is going to be 4, so we can put that point there. For the next graph, y equals to x plus 3 all squared. So again, if you want to work out where the vertex is, we're going to solve x plus 3 equals 0. So x is going to be negative 3. So that sort of tells us where we're moving towards. So there's negative 3. So what we're going to do is we're going to take that parabola, and it's going to go 3 units to the left, okay, to the value of negative 3. And that's going to be the graph of y equals to x plus 3 all squared. Now, with this graph, if I were to continue it up, it's going to go quite a fair way before it reaches the y-axis, because if I put in x equals to 0, you can see y is equal to 9. So we kind of need to have our y-intercept somewhere here. So we'll just leave our diagram like this for now. If you were drawing these graphs, you should always be making your graph cut through the y-axis and marking that point in. But for the time being, we're just going left and right, and that's how we'll draw it. Now, we've looked at dilations, which is stretching and shifting graphs. We've looked at vertical translation, so moving up and down, and now horizontal translations as well, left and right. What we can do is we can put it all together, and this is what that equation is going to look like. So remember, the A value was your dilation value, so it's telling you how much to stretch or squeeze it by. The H value tells you your left and right translation, and the K value is your up and your down. So what we can do is, rather than looking at each of those ideas separately, we can actually combine them all together. So if we were looking at this sort of example, this sort of equation, what we want to do is work out what each of those values are, and then that will help us to work out what our final graph is going to look like. So let's have a look at these two examples. So sketch the following parabolas, and we want to show the y-intercept and the coordinate of the vertex. So remember, if we were starting with y equals x squared, and I'm going to draw that in grey, okay, because that's sort of like our starting graph. When we're looking at y equals x squared, you can see that the vertex is at the origin. Then what we want to do is look at this equation, and this equation is going to tell us where we're moving this graph towards. So we're looking at the a value. So you can see a is going to equal to 1. So that means we're taking this same parabola, but then we're going to move this around a bit. Then we're looking at the h value. So you can see it's x minus 2. So then h is equal to 2. So that tells us we're moving 2 units to the right. Okay. Then we're looking at the k value. The k value is minus 1. So then that tells us we're moving 1 unit down. So what's going to happen to this parabola is we're going to take it, copy, paste. We're going to take this parabola, we're going to go 2 units to the right and 1 unit down. And that's where our final parabola is going to lie. So this is going to be the graph of y equals x minus 2 squared minus 1. We needed to find the y-intercept. To find the y-intercept, we make x equal to 0. So then we've got negative 2 squared, which is 4, minus 1, which is 3. So this value is going to be 3. The vertex, now we moved it 2 units to the right. Oops, 2 units to the right. 2 units right, and then 1 unit down. So then the coordinate at this point is 2, negative 1. And that's going to be our parabola. So again, no measurement. All we want to do is draw it based on the y equals x squared graph, and then we mark on any key points. Again, the x-intercepts we can find by solving the equation, but we're going to leave that for another day, okay, so later time. With example B, again, we need to look at each of these values, a, h, and k. You can see the a value is negative 1. So if it's negative 1, we know it's going to be upside down. So the first thing we know it's going to be upside down parabola. The second thing we know, if we're looking at the h value, that's a plus 3. And remember, it was minus h. So if it's x plus 3, then that's actually x minus negative 3. So you can see that's going to be a shift towards the left. So we're going 3 units towards the left. And then your last number is a plus 2. And the k value, we follow the same sign. So that's going to go 2 units upwards. So it's going to be an upside down parabola. So we're starting upside down. So let me draw that in. Upside down parabola. There's y equals to negative x squared. That's our base graph. We're going to take that. Take this graph. We're going 3 units left. 1, 2, 3. And 2 units up. So it's going to be about there. What I might do is I might just move my number line over a bit. So this new graph, let me just change that color. So this graph is going to be the graph of y equals negative x minus 3 squared plus 2. Again, what we want to do is work out the y-intercept by making x equal to 0. So then we've got negative 9 plus 2. This value is going to be minus 7. And what we also want is the vertex. So remember, we've moved this 3 units to the left and 2 units up. So then this point is going to be negative 3, 2. So it's really just following these steps here. Again, we can find those x-intercepts if we want to by solving this, but we're going to hold on to that until we start the Year 10 work. That's where we're going to do a little bit more of finding these values. Now, in your textbook questions, they don't really get to these sorts of questions where they've combined lots and lots of things together. Most of your textbook questions are just going to be one transformation rather than trying to put the multiples together. But eventually we will be putting all of this together, so it's good to see it right now anyway. So here's some questions that I'd like you to do. 14 to 16 are optional extras. Okay, if you get to them, they're well worth doing. But if you don't get to them, these are the questions that I'd like you to be doing.